In this third video for our vertex form, we're going to talk about actually the vertex form for a quadratic function. The standard form, which is what we mentioned at the beginning, is ax squared plus bx plus c is 0. And this is what our vertex form is going to look like. So to talk about that, I'm going to go back to example 2 and remind you that our vertex here was negative 3, 1. And notice how that matches up with this. We remember when we moved to the opposite of whatever the number in with the x is. So we went left 3, so there's your left 3, and then we went down 1. Oops, that was like wrong, wasn't it? That's really bad. That should be negative 1 right there. Sorry. And so anyway, you can see how these things match. Now what we're going to do is go back the other direction. If we know the vertex, we're going to put this back into this form right here. So here we go. When we look at this here, the vertex then is going to be to the right h, so h, and then k. So that's my vertex. The axis of symmetry goes vertically through that vertex through the h value, so it's going to be x is equal to h. If a, notice where a is, if it's positive, the parabola opens upward, so opens up, which means it goes, oops, I'm out of space there, it goes like this. And we'll say that the function has a minimum value at whatever k is when x is equal to h. If a is negative, then the parabola opens down, and the function has a maximum value of k when x is equal to h. So in that situation there. All right, so let's look at this here. So write a quadratic function to model each graph. For these functions, all values of the variable are either 1 or negative 1. Sorry about that. Kind of jogging you around. Or either 1 or negative 1. So we're not going to think too much about a right now, except whether it's up or down. So for this one, our vertex right here is negative 1, negative 3. So negative 1, negative 3. So when we write the function, we're going to have y is equal to, now since it's opening up, my a is going to be a positive 1, so I don't write it. Then I'll print parentheses x minus, so it's going to be the opposite of this, so minus a minus gives me plus 1. Don't forget the square, that's what makes it quadratic. And then the same as the y value, minus 3. B, this time it's opening down. But our vertex, 1, 2, 3, is at negative 3, 0. So our function is going to be y is equal, and since it's opening down, our a value is going to be negative 1. So here I'm going to say a is positive 1. So our a value is negative 1, so I'm going to put a negative here. Then x minus, so I want the opposite of this, so plus, make that be a plus 3. That means it's going to go left 3. Don't forget the squared. And then it's not going to move up or down, so it's just going to be this, and I'm going to stop. Then, so why don't I just let you go ahead and try C and D. So we're going to write try right here. So try and try for those. Example 4 asks us to write the equation of each parabola in vertex form. So this time it's just in words. I'm given the vertex is 3, negative 2, and I know that there's another point on this parabola of 2, 4, so that is also given to us. So now I've got the steps written up here to what I want to do. So if the vertex is 3, 5, then h is 3 and k is 5. So down here we're going to say that in this case h is 3 and k is negative 2. Then we're going to use a point on the parabola to find values for x and y. If the point given is 0, 4, then x is 0 and y is 4. So I'm going to come back here. Our point's 2, 4. So that means that x is going to be 2 and y is going to be equal to 4. All right. Now, step three, substitute those values into our formula for it's a vertex form of a quadratic function. So I'm going to rewrite this here. So y is equal to a x minus h squared plus k. All right, so y is 4. So I'm going to put a 4 in there. I don't know what a is. It's the only one not given to me. X was 2, so I'm going to put 2 in there. Minus h is 3, so minus 3. Then don't forget the square. Plus whatever k is, and k is a negative 2, so it'll be plus a negative 2 or minus 2. So I'm going to fit these in. Now what I'm going to do is I'm going to solve for a, and that's a little trickier than you think. So here's our steps. We're going to subtract the k from both sides of the equation. So I'm going to move my 2 over. So I'm going to do a plus 2 on both sides. So that's going to give me that 6 is equal to a, and then 2 minus 3 squared. You can probably do this in the same step, but I'll write that there. It says now add the numbers in the parentheses. So the next step says to do 2 minus 3, which is negative 1. Then I'm going to square it. So square the result. So negative 1 times negative 1 is 1. So we usually don't write the a in the back, so we're going to put this as really like having 1a. And 1a, of course, is a. So I get a is equal to 6. If this had been a number like 3, then I would have divided both sides by 3 to get an answer, but it's 1. So I don't need to divide by anything. So I get a is 6. Now it says fill just the values of h, k, and a back into our formula, which is right here. So that is going to give us that y is equal to a is 6. So I'll fill that in. X minus h was 3 squared, and then plus k, so minus 2. And that is my answer. We'll practice a few more of these next class. So see you then. You want to try? Why don't you go ahead and try this? We're going to put this. Oh, no, there's a try this down here. So do the try this right here and give that a try, and we'll have another one to practice next class.